All right, so the first step for this operation is going to be turning op. So let's get our part file loaded. So we'll file merge, or I'm sorry, file open. And I'm just going to load this 4-axis step file. This is the one that's provided on Blackboard, but I have it quickly right there on my desktop. So now we need to go to machine, lathe, and I'm just going to use the generic Haas ST post. And then let's get in here and check our material, stock setup, and all that kind of stuff. So we'll get into here. I'm going to go to tool settings, and I'm going to go from material for feed calculation. I am going to leave it on steel. This part will be steel, so 1030 steel will be fine for what we're doing. We'll be working with a 1018, but this will be fine. It'll be a little bit slower. So we'll go to assign tool number sequentially, Warner duplicate tool numbers, and we'll be good there. Go to stock setup. The stock for this part is going to be a 2-inch OD. The length, let's leave it at 4 inches for right now. And then we'll hit green check. And then let's take a look at this. I'll just hit green check out of here. And let's look at this. So the key here is that we have to not only turn this workpiece, but we have to do some 4th axis work on the milling machine to do these pockets. Okay? So that means that we're going to want to hang on to some material in the chuck here to do that extra operation. So this workpiece ends up being, let's see what the overall is. Looks like 2 inches long. So we could either hang on to 1 inch or maybe actually cut a longer piece. That way we have extra. I know it's excessive stock, but it's not the worst thing. I'd rather, there's a concept, I guess, in fixturing where do you make a fixture? Do you risk damaging the workpiece? You just hang on a little bit of extra stock and cut it off, and it's just scrap. This is mild steel. There's no material, real major material costs involved. This would probably be okay. But instead of hanging on to 1 inch in the jaws, you know, let's hang on a little extra. So stock setup, go in here, and we'll just go to a 5-inch length. Okay. Then we'll go to our chuck jaws. And for the parameters, I'm going to go from stock, and I'm going to change the grip length, let's say 1 inch, then I'll preview it. So that looks okay. That'll give me plenty of room to have 1 inch, 1.5 inches extra here, and have room for the parting tool. If we need to adjust the chuck length later, we can. Even right now, if I wanted to update it, you know, even 1.5 inches would be okay, which is plenty. Okay, so that looks good. Now, the reason I am doing that is because I'm going to turn this stock back farther, okay, then part it off. That way, the part that I will be hanging on to in the chuck on the milling machine will be concentric with the part and will minimize our indicating issues later. All right, so that's good. Then we'll hit green check and get out of here. All right, so that looks good. Okay, so that'll work for us. Let's take a look. One thing I just want to check here. I'm just going to estimate quickly. Top of the part here and go, let's say, to here. We're only hanging out 3.5 inches. That should be fine. I don't think it's worth centering this example. Okay. So what we need to do now for toolpath group 1 is I'm going to rename it as turning OD. And then I'm going to get into some rough settings. So I'll do a rough pass. Okay, or I'm sorry, I'll do a facing pass first. I'll get in a lathe library, just a regular CNMG insert. Make sure that is a CNMG insert. It is. We look okay. Face parameters, everything looks okay. Amount of overcut, I'll go like 10 thousandths. And I will double check my speeds and feeds here. Now, I will leave the spindle speed and constant surface speed. The 525 is fine for this. The only thing I'll reduce is probably going to reduce the feed rate to, let's say, 8 thousandths. But then the max spindle speed, I will cap it at 1,000. That is not necessary, but when learning, I find that there's no really need to be super rammy, so we'll leave it there. This will be facing in the comments. And everything else should be okay. We'll hit green check, and we have a facing operation. The next operation will be rough turning. Okay, so I will select the geometry here, change direction to here. Now notice it didn't work out. What I usually do is I'll just deselect everything, select again, and it worked out well that time. We'll leave it there, green check. Same tool's fine. I will update the max spindle speed to 1,000. This will be rough turning. And then the spindle feed rate will leave, let's go to 10 thousandths. And we'll leave it right there for now. Rough parameters, equal steps is fine. Depth of cut, 100 thou is okay. We can reduce to 50. Again, I don't want to push it, especially because this might be your first time working with steel. Stock to leave in X and Z, I'm going to leave 5 thousandths. And right now, that'll be okay. One big thing is I want to do is use stock router boundary. Very important. Okay. I will update the lead in, especially the lead out shortly. But for right now, let's just hit green check and take a look. Looks good. Let's adjust our lead out. Okay. The lead out, I want to go past about 1 inch. So let's extend that. We'll get into the lead out settings. Here, extend the contour, let's say 1 inch. And let's regen the operation. That looks good. Okay, we could probably go further, or we can grab more with the chuck. That's 1 inch past. Let's go a little further. Let's go like 1.25 inches maybe. The reason is because of the parting tool. So let's go like 1.250. All right, so that's better. So that's what the workpiece is going to look like. We'll part off right here. All right, so there's a roughing pass. I'll turn off the actual cutting lines here. And down here, let's do our finish pass. All right. So the finish pass, again, we'll select its geometry. It may prompt us and select 2. So again, I just get out of there quickly and just go like this. Green check. And everything looks okay. This will be finish. Now, for the finishing, I can allow the spindle speed to go up a little bit. The feed rate will be like 5 thousandths. And the finish parameters, in lead in, lead out, we will extend lead out 1.25. That should work okay. Everything looks good. The one thing, we're using mild steel, so the one issue we can have is that we are not leaving, it depends on what nose radius tool you're using. You want to take at least the nose radius to finish. So we probably want to increase this to like 15 thousandths. Just for right now. It might help with your surface finish. Again, mild steel, the trick that I have found is that if you take at least the nose radius of the cutter for a finish pass or for any pass, you get a good finish. It's when you take less than that it starts to rub and you get sort of a smeared finish on the mild steel. So hit green check. Everything looks okay, and that is our lathe operation. We can watch this and back plot quickly and make sure it looks right. And again, we're roughing and finishing with the same cutter. We're only making one part, so I don't think it's a huge deal. There it is. Looks good. The only thing I noticed that we are digging a little bit right here. That's because of that 15 thousandths left from the previous op. So in parameters for the finish operation, let's take care of that in here. And let's go to be 35, right? So now, in theory, that should not gouge. So we'll just backplot this again quickly. All right, looks good. All right, so that's it for the turning operation. Now we have to make the choice for the part off operation. Do we part it off right here and risk dropping the part, or do we do a stock flip and then we grab onto right around here? Let me do just an estimate here. You know, something like, you don't want to grab onto there, but you know, here to even here somewhere. About 1 inch to hang on to. That would work. I don't see a problem with that, even if we had to use a shim to grab it. So maybe we should do a stock flip operation, because my concern with this, or what would be, is that when you part this off and it drops, you risk dropping the workpiece and damaging it. So if we stop here and just do a stock flip, do a rough indication and part off this extra stock here, you know, who cares? You know, get rid of that material. Knowing that these have been turned in the same op. Okay? So right now what we can do is we'll do a stock flip. So we'll get into turning operations. And what I want to do is also, prior to that stock, let me just double check my levels. I have the solid levels, all this geometry, everything's okay here. I'll add a new level just in case. And let's do our stock flip. Okay, so select that. I'm going to turn blank original geometry off. Transfer geometry is going to be on. I will select everything. And then I'm going to offset the levels by 10. Everything looks okay here. So what I'm going to do is just a green check, and you'll see what happens. Okay, looks good. Now we can do a jaw adjustment, and we can see where it's going to end up. Okay, so let's get back into these parameters here. And the diameter that we're going to grab onto for the OD here, if I do a quick analyze entity check here of this diameter, it looks like it's 1 3/8. Okay, so we'll go to 1.375, and everything else is okay. The transfer position will adjust a minute. Let's just make sure the jaws move. That looks better. Okay, now what we need to do is we need to shift this part back. So let's get into levels and turn these two off. The blank one was irrelevant. We'll make sure the stock flip is active. And then some people will actually, you can make the jaws solid, but for right now, I'm just going to do an estimate here. Yeah, I want to grab right around, here to here. So if you do just a quick adjustment, it's like, 6 inches or so. So let's see how this works out. We'll go back into our toolpath, into our parameters, and we'll type in 6 inches. And let's see which way it goes. Okay. Wrong way. Let's try negative. Okay, that's better. Okay, the only problem here is that we were going to the chuck. The transferred position is all about getting it to the 0, 0. Okay, now you have to decide, where do you want this 0 to be? It sort of doesn't matter in a way to us. It's okay to be on this back surface. That sort of doesn't matter because this distance is really not a big deal. We could even have it set here and then part to that. You just got to be careful with your retracts. So what I'm going to end up doing is I'm going to set my 0 to this face, and we'll back reference to here. So let me just check where we're at here. Analyze distance. We'll check from 0, 0 to there, which is about 977 thousandths. Back on our parameters. Let's go into the transfer position, and it's going to be, let's say 5 inches for now. Let's see where we end up. Okay, that worked out anyway. Okay, that's probably about right because that 977 was just an estimate. So we're good there. So now we need to move our chuck jaws. Okay, so now that we really hammer down the transferred position, what that's about the actual stock and the part that's still hanging on. The chuck position, okay, becomes more critical. That is going to move the jaws to where we need them. So right now the stock jaws are minus 3.5. Let's go minus 2.5 and hit green check and see where they go. And you see what happens. It brought it in. Okay, if we go again, let's say instead of 3, let's just take away another 1/2 inch. Okay, that's not terrible. Okay, we can part off right here, right into this larger diameter. Okay, if you're worried about it and you want to go into here, you would have to hang on to less, but that's kind of up to you. I would prefer, you just got to watch which side the tool is. If you're using a center tool, it's not going to work here. Whether it's right or left hand, you need to be very careful of that. Okay, so we'll leave it like this for right now, and we'll either sneak right in here or we'll part off right here. Okay, so let's do a new turning operation. So up on the top here, right click, groups, new toolpath group, and this will be parting operation or op2, something like that. And now we can get into the parting operation. So I'll do a transition here and let you catch up, and we'll continue parting this off. All right, so if you watch the dead center video, I talked about the position of the stock and how to sync up the part to the new zero on the lathe. Multiple ways to do it. This operation is not super critical. As long as the parting tool goes where we want it, we should be fine. But know that, you know, it's expecting you to touch your tools off to here, or like what I would do is I would touch the inside of the tool to here and then back up whatever the distance is roughly, and then set, you know, part zero set again real quick. That way you're touching off to a known and then back referencing a number that is known, whatever Mastercam thinks that this number is versus what actually exists. Because this could be saw cut. It really is sort of irrelevant. Okay, we're not going to face it. We're just parting off. So we need to create some geometry. There's nothing to click onto to define the boundary for this. So what I want to do is I'm going to go into wireframe. I'm going to select the center of this arc and just come up 90. And then I'm going to go divide and trim it up. And then I'm going to select this line here at the intersection. Be very careful how you select. All right, note that'll go to the center. So look for the X to pop up. Okay, I'm trying to hold it so we can see it. All right, there. And come on over. Now we'll just click. And this endpoint is going to be wherever our parting tool is going to go. Okay. So if we want to go right around here, let's just go 1.25. Okay? And hit green check. So that's the end. That's where our parting tool is going to go. All right. So now what we need to do is get into turning, cut off, select the edge of that. I have a cutoff tool selected. Okay, but make sure it matches what you have at the machine within reason. Okay. And I'll make sure that the length here will clear a inch part, which they should. Okay, so for the feed rate, we'll go 2.5 thou per rev. Spindle speed 200 will be fine, and we'll turn the max spindle speed to 1,000. All right, and that will be fine. It's a little slow, but it'll be okay here. We'll make sure the coolant is on. It should default, but make sure that's on. Same with the other operations. Everything here looks okay. You can do different operations like a peck in the parting tool, which is not a bad thing. It actually does work out well. You know, if you do a depth of, let's say, 50 thousandths and use retract moves of 50 thousandths in increments, that works well. Okay, so we'll hit green check and we can try that. And then we hit green check again. All right, and we have an issue. This tool starts embedded in the stock. So let's go back in these parameters. And the entry amount is usually the issue there, so we'll go from stock. Green check. Much better, no warning. So let's take a look at this operation. Okay, let's watch it in backplot. And let's see where we're going here. Now, it looks like it's cutting pretty close. See, that is actually ideal. It's up to you how close you want to get to the chuck jaws. We could start over here. We could move our jaws back. It's totally up to you. What we can do is I'll actually just update my stock jaws here. So we'll go 2.25. So we'll position that back a little bit. Okay. The parting operation can now be regenerated. And now we have more room. And if that makes you more comfortable, great. You could wrap shim around this. Or, you know, use a little piece of aluminum or plastic shim. The amount of run out here is somewhat critical. I mean, you don't want it running out like 30 thousandths, but 5 thou run out is not going to be the end of the world on this operation. So again, if we get into backplot and watch this, okay, that's right on the edge of the workpiece. Okay, and works its way in. Okay. Now, what it's cutting right here is about 15 thousandths of material. It should be fine with that. I personally would not worry about that. If you are worried about it, you can update this line to go 15 thousandths to the left. Just right click, analyze entity properties. And instead of 1.25 inches, I'll just change it to show you. It'd be 35. Hit green check and it moves, regenerate the operation. And if I get into backplot again, and I'm hitting S on the keyboard, you see now that we are right in line with the edge of the stock. Okay? So that should work out fine for this. This distance here is what I'm worried about, but this is only 2-inch stock. You only got to go an inch into the workpiece, so it should work out just fine. Make sure it syncs up to what you have in the shop as far as the actual tool you're using. And we are good to go here. So it's a good time to save. And I'm going to minimize the turning OD operation and the parting operation here. The one thing here, this works out well. I do want to go into the parameters and the stock update. Okay, the stock update's critical. So take a look, regenerate operations, all this other stuff, but cut off stock. You want to keep the separated piece, keep the piece in active chuck, or keep both pieces. What are you doing for the next op? We're only keeping the piece in active chuck. So hit green check, green check. That part is really gone. So it really represents what is actually happening at the machine. So good time to save. I'm going to do one operation here. This thing's ready to work with. So what I'll do is I am going to do a new operation, a new toolpath group. And this will be stock model. And what I'll do is I'll do a stock model of what exists here. So I'll go to turning operations, stock model. And this will be from turning. The stock plane, we could leave there for now. The original stock is going to be the lathe operation, or we'll go cylindrical and we'll just do this from the stock setup. The material can be glass, that's kind of default. The source operations will be pretty much everything. All right. So hit here and hold control and go here too. The path tolerance 5,000 is fine. We talked about that in another module. This should be okay. So let's hit green check. All right, and let's look what the stock model looks like if it computes. Okay, there it is. We do have one issue though. We have this remaining stock. So we can't really use this necessarily, this method, okay? What I recommend you do is if we get into, what we'll do is make sure that the cutoff is on. We'll get into verify, and what you can do in verify is you can actually just play this and you get what you want, which we've seen this already. But in the verify window here, you can go save stock as STL. So we'll save it. I'm going to put it right on my desktop. Okay. Then we'll hit save. Okay. That's all set. So now I can X out of here, and I'm going to turn a new level on. Make sure it's active. I'm going to go to File, and I'm going to go to Merge. I'm going to go down and look for that STL file, which should be right in front of me somewhere. And I'll go to the desktop, and I'll find it, which should be right here, and hit Open. And there it is. And I'll say green check. Okay, because the position usually comes in correct. But notice the STL is only what was left, not this additional stock. Okay, so it's up to you. You can leave this stock model to update later. It's not going to hurt us. It's probably not a bad idea to leave it. So we'll leave it there for now. But that was another way, or the way that I would use to get a more realistic model, you know, of the remains from the turning operations. So for right now, what I want to do, the levels are good. This is right. I want to rename this. This will just be stock from turning, something like that. And what we can do now is clean up our tool paths. I will double check my operation here. Everything looks okay. Minimize that, minimize that. We are pretty much done with turning now. So now we need to change over to milling. So to do that is actually going to be right click, groups, new machine group, mill. Okay, and now mine defaulted to mill default. I do want to replace that with the generic Haas 4-axis mill. Okay, and that content folder will be available on Blackboard. So hit open. Make sure that's there, then hit green check. So I'm going to rename this machine group as turning. This machine group will be milling. Okay. And then I have some changes to make, but for right now, I will put a transition in and I'll let you catch up. All right, so I want to make some view sheets. I went up to the view tab, turned the view sheet toolbar down here on. I'm going to minimize milling for now, but in turning, I'm just going to go to the stock flip, and you can click around, and here's our first operation. So we'll go like that. And what I'll do is, I also went in, the levels are only on solid, the only one I want. I can right click and save view sheet bookmark, and we can rename this view sheet as op1. Make a new one. This will be op2. Now we need to change some things here. We'll get into the next solid, and then we'll click the update for the on the stock flip operation. It wouldn't be a bad idea to have this as a separate toolpath group, but it's okay. This is not a lot of operations on this one. And then we can right click, save view sheet bookmark. And after that, we can get into the milling operations. So now we're done with turning for now. Okay. And we can then focus on milling. So for the milling operations, go to tool settings. This is going to be a different material. So we're going to go to steel, which is fine. It's going to be from material for the feed calculation, warning of different tool numbers and duplicate tools, things like that. The stock setup is going to be a different solid. So I need to go into, I'm going to green check right now and open that up. I need to get into levels and turn this on here. Okay, the stock, the STL file. And what we can do is I'm going to go back into toolpaths, back into stock setup. Okay, notice it's rectangular, it's going to get confused. Solid mesh, click, click, hit green check. Okay, that's what we're looking at now. All right, so we're set there. We could have done a stock model, same thing, but just be very careful with the shape. Okay, solid mesh allows the odd shapes, cylindrical or rectangular, and all solids would create either a rectangle or a rectangular stock or a cylindrical stock based on the inputs of that all solids function. So hit green check, and we're good there. Okay, so now what I want to do is do a new work coordinate system. Okay, so I'm going to do dynamic, and I'm going to place it right on the edge of this workpiece. Okay, notice though, there's nothing there. Why is that? This is an STL. The part is not there. So go into levels and go into level 11, and then you could even turn that one off, and notice you have your 0 again. Okay, click. We're good there. Okay. What I'll do also now, just to be careful here, is go into stock setup and turn display off and hit green check. All right. Go back in, and just to show you how much easier it is, when you're working with geometry, you get much more confidence in what's going on. Go over to the radius, click. You're good. Okay. The STL files are not, circles, cylinders, cones, things like that. They are a bunch of small triangles mixed together, and the selection can become difficult. So that's good now. This will be for milling. It's important that you know where your fourth axis indexer is. Ours are going to be placed over to the right typically, and the X positive is that direction. Everything here is good. We'll hit green check. There's our new op. Okay. What I'll do is you could even do your stock like that. That's fine. I'll do a new view sheet. This will be milling, or op3. All right, and right click, and you can go save view sheet bookmark. Okay, and you can click through these, and it moves everything around. All right, so we're good there. Now this toolpath group will be the indexing, or I guess we can call it. All right, so now we are ready to do these 4 pockets and this hole we need to take care of. Okay, I am not going to do any fixturing for this one. The jaws will be over here, and we should not be near them at all with this op. I can import the whole indexer and things like that, but I don't think it's worth it for this example. If I was actually worried about it, I would go out and measure the chuck and just create a cylinder that is the OD of the chuck to stay away from, to make sure I'm watching out. I wouldn't go crazy with fixturing for this one. We are not going to be really running that close. We are going to be grabbing over here. Okay. So for right now, we'll do a transition, and then we'll start our milling operations on this workpiece.
Alright, let's mill these 4 pockets. So to do that, we'll go to levels. Let's just get rid of our stock geometry here. Go back in toolpaths, and we just need to do a basic contour operation, okay? I am going to select the bottom of this slot and change direction here and work my way around so that the cutter, it's essentially going to be just almost a full width of cut here. But I do want to try to get some sort of, I almost always chain for conventional climb cutting if I'm thinking about it. Green check. Tool is going to be a 1/4 inch flat end mill. Okay. The speeds and feeds are okay. Again, the reduction is coming from here. We could probably get away with a faster chip load and surface footage. I know when I put these specs in, either looked them up in HSM Advisor, the surface footage was like 205, and the feet per tooth was 1.6, so about double that. But this is fine for now. This will work out. Rapid retract. The plunge rate will change to 6.5 because we are plunging outside the workpiece, and this will be a 0 point. In cut parameters, we'll go to wear compensation in case we need to compensate for the size of the workpiece. Depth of the cuts will turn on for a max rough step of 50 thousandths. Lead in, lead out, we'll leave the defaults on for now. Linking parameters, I will leave them all incremental, including turning on the clearance plane. The depth is 0. Top of stock, I will select the apex of this pocket here. That'll be the outside of the stock. 87 thousandths from the chain geometry, that's fine. Arc filter is not necessary, planes will be fine. Make sure it's set to manual and 0. That'll force it to be G54. So that is important. We could change that later in the planes dialog box, but it is a good idea to make sure you have work offset, manual, and a 0 there to force it to be G54. Coolant should be on, and that's it. So let's hit green check, and there is our toolpath. So nothing too exciting there. What we need to do is get some rotation to do the rest of these. So what we need to do is go to planes, and I'm going to do either a new plane, or we can right click and duplicate this plane. Call it, 90, let's say. And notice that it has a 0 in the offset. This is where you would change the work offsets in the planes dialog box, but since we copied it or duplicated it, it already brought it with it. We can change this 90 to the current C and T plane. Okay, and then we need to right click on it and edit it. And what we need to do is rotate it -90 to get to the next pocket, so that the Z is perpendicular with this pocket. Then we'll hit green check. We'll just manually move it around here. And then we can go to toolpaths, and we have 2 options. We can copy and paste and rechain, or because Mastercam usually keeps a lot of your settings you just entered, you can go into contour, and I'm just going to rechain this because we have to rechain it anyway. And then we can go green check. Everything should be the same. I'll double check as I work my way through. This will be a 90. And then where depth of cuts is all the same, lead in, lead out is the same, linking parameters look the same. The only thing that's going to change, and hopefully you don't have to select anything, is in planes, T plane and C plane are now 90, not milling. So the change from a WCS to a T plane and C plane normally, depending on post processor, kicks out an A move or some sort of rotation. Okay, the coolant will be on because it's the same from last time, and then we can hit green check. So there's our next operation. Okay, let's do that again. We need to rotate the WCS again. So what I'll do is I will get back in the planes, and I will right click and duplicate the 90. I'll change it to 180, make it current C and T, then I'll right click and edit it and rotate it -90. Hit green check. So now we have our new plane where the Z is perpendicular to the bottom of this pocket. Go into contour, select the chain, walk it around, green check. Everything should be the same. Okay, I don't see any changes. I always just double check. Everything looks good except for the planes is now T plane and C planes 180. Watch out for that 0 work offset. Green check. There's our next one. Let's finish the last pocket. Okay, so I'll duplicate the 180. I'll right click and change it to 270. make it the current C and T. Right click, edit, and I'll pivot this around about the Z, -90 again. Then we'll hit green check. Everything looks good here. Back to toolpaths, go to contour, chain the geometry. Okay, make sure you change direction. Like that, green check. Tools the same, speeds and feeds look okay. Cut parameters, looks good. Depth cuts is good. Linking parameters look okay. Arc filtered is irrelevant. Tool plane and C plane are 270. Manual work offsets. Coolant is on. Green check. So now we have all 4 pockets. Okay. So if I select the indexing operation here, the one thing I think I did forget here, let me make sure I renamed this. Okay, so this would be A270. Something like that. Okay. So in backplot, we can watch this run. Okay. There's that last pocket we did. Let's select everything. We can go to our last view sheet. Alright. We can watch this run. Okay. We can watch this in verify. I gotta see what it comes up with for our stock setting. I should have checked my simulator settings before I did that. See what comes up here in simulation. Okay, it looks okay. So let's turn the precision down a little bit. And I'll turn the speed down a little bit. And we'll hit play and watch it run. Okay, op change. Op change. Okay, looks good. Okay, let's take a look at the code. Alright, so we'll post this, just this operation. I'll save it. And let's take a look at what this looks like. Make sure everything, I'll just go through what I look through when editing one of these programs. Okay, so we have A0, the comment, A0, looks good. Now it's not that important that these sync up in this operation. It depends on which way it's going. It should sync up, but I'm not going to go back and tweak it if it's, if it'll actually work okay. So the speeds and feeds are all there. There's our, rapid down. Everything is positive, so that looks good. The Z 0.3937, and then it goes around, comes back on, but it's going to Z 0.350. If we get back into Mastercam, and I'm going to turn the level off for the stock. If I right click and analyze distance from here to here, in the Z it's 0.350, so that's correct. We're setting our 0 in the center of the word piece. So take a look at the code again. So we know that's good. Take a look around, go to A90, so it moves up in the Z. A90 in the comments, smoothing settings for a Haas machine, A90, then it starts cutting again. You go around, there's our Z350, comping to the left, everything looks good. We have an A180, we're missing a comment, we will fix that. So A180 is next. We got our Z350, A270, and we're done. I will make sure that I see a G54 in the search and the find and replace. I'll look for G55 to make sure it's not there, to make sure I don't see any other work offsets. So everything looks okay in here, except for I'm missing a comment on my 180. So I will put that in. So I'll put A180. That's good. Good time to save. And then what I'll do is I'll transition here, and we'll take care of the hole here on this side of the workpiece, and we'll probably helix bore in that with an 1/8 inch cutter, is what I'm thinking. And then we'll be ready to part this workpiece off. Alright, so I'm going to turn the visibility for these tool paths, the previous tool paths, off. And then I'm going to minimize it. And then I'm going to right click on the indexing and create a new toolpath group here. That way it's synced up in line with the contour to be ran at the same time when selecting the indexing operation. This will be whole. Okay. And what we need to do now is take care of our plane. So there's different ways to do this. Okay. And depending on your post processor, if you program 5-axis parts, at least in the UMC 500 post or UMC 750 post that I have, you can just assign this plane at, you can just do from geometry and assign a new gnomon to this plane, and the location of that gnomon is not critical because using dynamic work offsets, it takes care of, it knows that this is 0, 0, and that is just a rotation. It won't take X and Y points necessarily from there. Okay, that is not the case with this post. So what we need to do is we have a couple options. We can rotate it knowing that this is 45 degrees, or we can go into planes and we can just do a new one from a solid face and select this face. We'll kind of get it lined up, okay? But now we should move it back to here. That just took care of the angle orientation so that it's perpendicular to Z. So what I would do, all right, is what we need to do is move this around. All right, so you have a couple options for doing that. All right, you can hit green check, and then you can right click and edit it, and then you get a dynamic gnomon. Okay, and that's the way we'll do it because I'm already there. And that allows you to, again, I use the dynamic gnomon all the time. All right, that is not a bad way to go. The other way to do this, if I just delete this option, I'll just make this one live. Right click and delete this selected plane. If you go back into here and you can go to dynamic, and you should be able to snap it, okay, to this plane. Okay, anywhere in here, it doesn't matter, on that plane. Okay, because once it's snapped to that plane, as far as sitting on it, like it is when we look at this transparent, okay, notice it's there. Okay, we can now move this in any axes, okay, that we want. We don't need to worry about rotation now, so we can actually just click this. It'll keep the rotation, snap it to the middle, okay, and this will be whole, wherever that might be. So that was a quick way to take care of the angle of this hole without actually looking at the drawing and calculating it. You could, you know, you could use drafting, you could use analyze entity properties, things like that, but it was just a quick way to do it. And I'm sure there's other ways to do that. But we will go to manual for the work offset and call this 0 while we're at it. We will not set it as world coordinate system and hit green check. So there it is right there. Okay. So now what we need to do, and again, it is important that, and you can change this at any time, but that the WCS remains at milling, because any op we create after these are selected will have those in the planes already, as you saw in the previous examples. Okay. Notice, nice thing about this, and you can change these settings, is WCS milling, that's 0, milling 90, milling 180, milling 270 for the T-plane changes. So now we can get into a drill operation. And I'm just going to select this geometry down here and hit green check. It's a 3/16 hole. We will go to tool, select an 1/8 inch end mill. Now these speeds and feeds are slow. Let's double check the end mill to make sure we're all set here. We are. I don't see anything that we're going to edit in there. If we reinitialize speeds and feeds, again, that is on the slow side. Okay, speed and feed calculator, let's take a look. 12%, 100% for surface footage. This is picking up like it's a drill operation. Okay, let's hit green check and get back to toolpath type and try helix bore. Go back to tool. Okay, right click, reinitialize. See the improvement. Even though you're using an end mill, it thinks, especially when you go to the calculator, it thinks it's a drilling operation. So when you see that reduction for drill that we saw before, that was there. Okay, just to bring that up. So this is okay. Again, if you look at HSM Advisor, I have these set up. The 205 surface footage and a almost half a thou chip load is there. This is a little on the slow side. The chip load is about the same, if I remember correctly. But the surface footage is slower. That's fine. This will work for this example. The plunge rate, I'm going to leave the same for right now. I want to make sure that it doesn't. It shouldn't. It should be feeding at this rate. But we'll double check on our code and update this later. Again, this is not moving a lot, so I'm not super worried about it. If we were really looking for efficiency, I would be tweaking these settings. And again, even the tool stick out, again, that changes things. In HSM Advisor, you can see the increase to a almost 8/10 chip load for this cutter in that operation. Okay. And again, I have circle ramp settings on depth of cut 10 thou, and that's going to be as we helix bore in. And again, HSM Advisor is available at the college. I do like the speed and feed calculator, but I do use Mastercams often too. But I just want to bring this up. A couple people mentioned this. It is available on the computers, in case you were not aware of that. So right now we're set. This will be the hole. All right. Go to cut parameters, we'll go to where comp, and we're going to leave nothing on this. We'll leave comp on the whole time. Start end at center, perpendicular entry, overlap of 20 thou, start angle 45 degrees. Rough and finish, we'll do a 10 thou rough pitch, nice and easy. Feed rate at final depth be 30% to do the last little bit of cleanup, so that's fine, nice and easy. Whole segments, linking parameters, 0. Top of stock we're going to change to there. Okay, everything's incremental. 0.2 for the retract, so we're good there. All right, arc filtered is not important for this one. Planes, the WCS is the same throughout. It's going to be pivoting about that, and a axis move, T-plane to and construction plane right here. Okay, override the manual work offset was already done in the previous when we were messing with the planes. We'll check coolant, make sure that's on, and hit green check. And then you'll see our operation. Looks good. Okay. Let's select everything here, and let's verify it quickly in simulation. There's our first one, second one, third, fourth, and I'll slow it down for the helix bore. Okay, looks okay. It's only a 4-minute runtime, so it's not that big a deal. Again, we're only making one, so we get the luxury of having most of the time being in setup anyway, so a minute here or there is not going to be a big deal. Let's only post the whole operation, and let's just take a look at this separately, already knowing that we reviewed the other portions of this. So let's take a look here, and take a look, let's see what we got. So the comment should be whole. Yep, and then we have an A135, which is right. And then we have a Z locations. We have an X positive and a Y11. That's fine. Let's make sure we're going to the right depths. All these depths look okay. Again, 350 was where the flats were here. Okay, so being less than that makes sense. Again, we're less than that. 312, 412, 312. If we take a look at the 312 location, if we go to analyze distance from the center of the workpiece to this apex is 312, so it's going right to that top of the workpiece. And then feeding in, notice it is feeding in at 6.2. The plunge is 3.1. We'll go back and change that before we go to the next operation to make sure that that's the case. It's a good idea to double check what Mastercam is thinking, plunge versus when it's plunging, when it's not. Before you go to run something. So it goes down, all the way down, and then it stops at 212, and that is our final Z depth. So let's see if that's correct. Okay, get back to Mastercam, go to the bottom of this hole. 212.5 in the Z, that is correct. Alright, so the code looks okay. Alright, goes back to A0 when we're done, wrap it up, everything looks okay. Cutter comp cancel is in there. Okay. We got a comp on, looks good. Alright, G54, we'll search for G55 quickly. It's not in there. So code looks okay. So Xing out of our code editor, we'll get back into our parameters, update the cut parameters, or I'm sorry, the tool settings, the plunge feed rate to 6.5. Feed rate, hit green check. That automatically regen. Again, if you're in 2021, you don't have this generate toolpath option. 2022 and newer will have that, so regen it, and that's it for this one. Okay, I just want to make sure again we do not we got to make sure we have some lead-in moves. I always check this on the helix bores because the comp needs to have a linear move to turn it on. Okay, now we have our lead-in. You'll see our lead out. Our lead out does not. Okay, that's right there. So we need to get in our parameters and tweak that a little bit. Otherwise, we could have cutter comp interference at the machine. Okay, the overlap's fine. The entry exit arc sweep, we can put that to 45 degrees as well. Green check. Okay, now we have straight line moves on and off this workpiece. Okay, so that's pretty good. The other thing we could tweak on this is we really don't need to start and end at center, so we can green check and regenerate and see what that does. Okay, again, not really good for our comp turning on or off. If we were using computer comp, that would be fine. We can try start at center and see what the changes are. again, we can go to end at center. Okay, you could also change perpendicular entry off and see what that changes. Okay, which is how we're going to leave it, just like that. Okay, we would call that a teardrop shape. That's a good lead-in because you need the G1 moves for the comp to turn on and off. But it's nice to arc into the workpiece. It's a smoother transition, and you're less likely to see the entry and exit of the end mill into the workpiece. Okay, so we'll take a look at this whole thing again and verify quickly. So there's our cut in the one, cut in the next one, third, fourth, and helix bore. Okay, looks pretty good. All right, I would just double check your speeds and feeds and make sure that makes sense. Again, we're running pretty reduced, but that's okay. These should be fine. 410 ship load is fine, and then all of these should be okay. But you can go ahead and double check that yourself. All right, so that's it for milling this operation. Okay, I'll put the red cursor down at the bottom, minimize this, save the workpiece, and now we're ready to cut the workpiece off, and we'll use the wire EDM to do that.
Now I'm going to go into machine, wire, and I have the ONA conversational post here. We use ONA wire EDM here. That will also be on Blackboard for you to drag in and use. The wire is identical to lathe and mill in that aspect. So we'll go to that machine group. Now we have this machine group 1. I'll rename this as wire op or wire EDM. All right. And now I'm going to milling, and I'm going to turn these tool paths off. And now what we need to do is we need a new 0, 0. So in the wire, we're going to hang on to the part itself in a V block most likely, and we'll run the wire right along here, getting rid of this line or this stock. We'll hang on to the part. That is the best way to do it. You don't want the part to drop if you can ever avoid it. So right now, what I want to do is I'm going to go to planes, and I'm going to do a new one, dynamic. And I'm going to zero it. We have a couple options. We could zero it right here, or we could bring it and zero it right here where we can actually touch off, which is probably not a bad thing. To do that, I am just going to turn my stock off, and that way I know I'm on this diameter. Okay, so that's that. Now what I want to do is I want to change this. I'm going to rotate about the Z, -90. Because we're going to put in the machine Y positive being that way. Okay, so that's good. All right. Let's hit the gnomon. Okay, and it looks like we're in good shape. I will double check this. I did click, and I wasn't happy with that last click, so I'm going to make sure that the gnomon is in the right location. So I'll click the center again, go over to the circle, green check, green check. So we're happy there. Okay, this will be rename this wire EDM. And now what we're ready to do is create some wire geometry. We really don't need any 3D geometry for this. We're just going to come in and cut straight off. So to do that, I want to break up this a little bit. So in levels, you'll see that's the whole stock. I'm going to take these two lines, and I'm going to place them on another level. Do not delete them because it'll get a little wonky on you for your first lathe operation. But I'm going to put this on another level, and this will be level 3, and I'll call it lathe 2D geometry. Okay, and hit green check. Propagate, and get out of there. So I'll turn that off. Now I'll do a new level. I'll rename this wire EDM. And now I can go to the wireframe, go to line, and I'm just going to select, let's say, this arc here, and I'll create a line over in space. Something, you gotta be careful here, you're working with 3D models, it's kind of click happy. So we'll go here, and actually what I can do is I'm just going to go to midpoint for this. That way I get a line that's out like it goes both ways at the same time. And I'll click somewhere in here, make sure that the perpendicularity icon is on when you click. And then the length, this is the worst case scenario, this is 2-inch stock. So I'm going to go 2 point, let's say 1. All right, 50 thou a side bigger. Okay, and we'll hit green check. Now if we turn our stock back on, actually I lied, I forgot that stock is gone. So let's tweak that again. If I right click on this line, analyze entity properties, let's go to 1.4375, or actually even 1.4 will work for this workpiece. So notice it only changed one side of it. Okay, see how it tweaks it? So what I would do is I'm just going to delete it and go back and do it again because I think it's faster than messing with it. Okay, we'll make sure we're 90 again, and we'll go 1.4. Make sure that it's away from the workpiece. That will work just fine. Okay, again, the wire's slow. You don't want to go any slower than necessary. Okay, if you're worried about it, 1.4375, 1/7/16 will be fine. So go to top view. All right, now we do need to put some lead-in moves in here. So I am going to put a line, not on midpoint, but 2 endpoints here, vertical. Let's say 0.030, 30 thousandths is fine. Green check. I'll put another one over here. 0.030, green check. So there's 2 lines. Now, we got to start getting into some different geometry now. So in point position, okay, go to point position, and I'm going to go to thread point, select here, go to cut point, or thread point, hit apply, cut point here. Then hit green check. That's what's going to thread the wire and cut the wire. Okay? Our 0, 0 is on this plane. Okay? So when we get to the wire, I'll show you how to locate, but we can't locate out here on the edge because it doesn't mean anything. We want to locate off the part itself. So, back into toolpaths. It doesn't really matter about stock right now. I'm not even worried about setting up stock here. We can. It'd just be solid mesh, and then you have to go into your levels, select the stock, and hit green check, and you'll see it'll highlight. But again, I'm not really worried about it for this example. It does not make a difference for us. Okay, notice it's not even displayed. If it displays, I'm not worried about it. You can define it, it's fine. Put it green check. Okay, let's actually, just to make sure, we'll display and hit green check and make sure it's right. I did notice that see, I was wondering about that. It's working a different work offset. So if we go up to stock plane and go to wire EDM and hit green check, and hit green check, still out. Again, the final fix, stock setup, go into the original top plane and hit green check, and it should move to the right location. So we're good there. All right, I am going to turn the display off for that, hit green check, and then I am going to turn the levels, turn off stock, and then here, we're good to go. So, in toolpaths, I'm going to rename this wire op, or part off, something like that, cut off, whatever. We need to go into wire paths. Now, one thing I want to do now is delete these lines. Sorry for bouncing back and forth, but those lines can mess you up. This point and this cut are what you need. We created those small lines to put them in. Here's the line we want. Okay, so now we're ready to go to wire paths and contour. We're just going to select this line, but you have to select the thread and cut at this time too, which gets a little confusing. Okay, so select the thread, hit apply, select the line, hit apply, and select cut and apply, or end chain, and hit green check. Now we get into here, and do not worry about anything with this library. Wire diameter be 10 thou anyway, but all of this is irrelevant. All of the cutting conditions are in the computer at the machine, and we will enter them at that time, and the post processor is set up for that method. In cut parameters, we are going to perform a rough cut. I'm not even worried about tabbing this. Tab would be a break. We'll cover that later. This is just going to cut right off. I'm not worried about it. It's only one piece, it's going to drop, and it's not moving far, so it's really not that big of a deal. Compensation, we're going to use control, and auto is fine. It should guess to the left. We'll double check that. We might have to force it to the left. Stops, not worried about for this. Subprogram, all that stuff I'm not worried about. We're good here. tabs, lead distance, all this stuff is not going to affect us for right now. I'm not even worried about the rapid height, all this stuff. I'm not even going to look at this in 3D. All right, planes, make sure it's wire DM, hit green check. Okay, it looks good, green check. You'll see our wire path. Okay, if we backplot this and we turn the holders off, you'll see the wire here, and it cuts on the left, on the right, on the correct side of the workpiece. Okay, looks good. Again, I am not worried about where this exists for right now. I don't want to focus on that. I'd rather get you at the machine, and you could tweak that if you want. All those settings are in the the UV settings here, right here. So the rapid height, UV trim, all of this is there, but that's only, in my experience, only ever used for if you are doing true fourth axis work, or some tapering, but a lot of machines don't care about that. All of these settings, for the most part, at least on the ONA, are in the machine, and when you set up your different planes at the machine for tapering, but we're not tapering. I don't even want to worry about it. I want to focus on just getting a simple program to the machine. So that's that. Let's post this wire EDM code. And let's see what it looks like. Okay, very simple. We'll load the data here, very empty up here. Travel at location, set coordinates, the thickness, and the PRGP will set at the machine. Thread the wire. The technical data will set at the machine as far as the thickness, but the criteria and the trim, which we'll cover when we cover the wire in lab, are separate. We are comping to the left. Y 0.5. X to all the way 718, Y 0.530. Okay. So we're good there. Comp off, wire cut, end. So this program's good. Okay. Remember the 00 is here. I will show you how to do this at the machine when it comes to the machine setup. Again, this part is done. So we just wired it off. This will be sitting in the machine when you're done. Okay. So if you have any questions, shoot me an email. You could do the same thing in the lathe if you like, but I figure if we put it in the wire, it'll get people a little bit of wire experience, and it was just a change of pace. So we got lathe, mill to wire in one workpiece. So what I can also do here is I'm just to finalize my view sheet. I recommend you do this. So this will be Op4, and right click and save view sheet bookmark. Okay, Op1, Op2, Op3, Op4. Okay, so that's it for this one. If you have any questions, let me know. And thanks for watching.